Good morning, children. Today's class we are going to recall certain properties of polar form. We have already learnt cos m theta plus I sin m theta or alpha, let me say, into cos n beta plus I sin n beta. Suppose you have a pattern like this. How do you multiply? If I want to multiply, I will remember add the arguments m alpha plus n beta plus I sin m alpha plus n beta. So it's a pattern that we have to remember. When we multiply two complex numbers in polar form, add the arguments. Suppose my question is division. It is just the same, but I write minus symbol. So multiplication means add the arguments and division means subtract the arguments. The very next idea, denominator I have like this. I take to the numerator as the conjugate. Denominator term goes to the numerator as conjugate. So these are the things that we learn. And then a very important property is de Moivre's theorem. What does the theorem say? Cos theta plus I sin theta, the whole power n. The whole power n can be brought to the argument cos n theta plus I sin n theta. It's a very important concept that we learn called de Moivre's theorem. Some famous mathematician, and this theorem is a great milestone in learning complex numbers because raising to the power is a difficult concept in maths. Addition, subtraction simple for many of us. Multiplication, division itself is difficult. Further, raising to the power n, that n can be positive, negative, rational number, that is any fraction, 2 by 3, 3 by 4, minus 5 by 6, anything can come. So de Moivre's theorem states the power can be brought to the argument. So the whole power n is very much simplified with the right hand side cos n theta plus I sin n theta. So we are going to apply these concepts in this exercise. Exercise 2.7, question number 5. We are given cos alpha plus cos beta plus cos gamma is equal to sin alpha plus sin beta plus sin gamma equals to 0. We need to show this result. This 3 alpha, 3 beta, 3 gamma says I want to raise to the power 3. Remember de Moivre's theorem. If I have 3 alpha, it should be the whole power 3. So for which I must take to the whole power 3, it should be polar form. How a polar form will be? Cos plus I sin. So there are 3 arguments given. Let me consider cos alpha plus I sin alpha. Treat this as some complex number A. Then tell me B. I have written one with alpha. Let me write the second with beta. So how shall I write? Cos beta plus I sin beta. And let's see B. The third one, gamma. Cos gamma plus I sin gamma. What happens if I add it all? A plus B plus C is equal to cos alpha plus I sin alpha plus cos beta plus I sin beta plus cos gamma plus I sin gamma. What do you mean by addition of complex numbers? We take all the real together. Cos alpha plus cos beta plus cos gamma. Then all the imaginary together in which I is common. Sin alpha plus sin beta plus sine gamma. Now look at the very first result given. Call this as number 1. So from 1, this is 0. Cos alpha plus cos beta plus cos gamma equal to 0. Plus I into this is also 0. So the entire thing equal to what? 0. So I have proved A plus B plus C equals 0. In algebra, whenever A plus B plus C is 0, we have a famous result with cube. See, 3 alpha is my question. So I must recall something related to power 3. And whenever A plus B plus C is 0, we remember this famous result in algebra. A cube plus B cube plus C cube equals to 3ABC. We know what is ABC from here. So let me substitute. So 2 implies wherever A is coming, cos alpha plus I sin alpha the whole cube, B cube, cos beta plus I sin beta the whole cube, C cube, cos gamma plus I sin gamma the whole cube equals to 3. A into B into C. What is A? Cos alpha plus I sin alpha. And what is B? Cos beta plus I sin beta. And what is C? Cos gamma plus I sin gamma. So A into B into C we have written. Now let us recall all the properties that we learnt a little before. Power by Moivre's theorem will come to the argument. So this step can be rewritten as cos 3 alpha plus I sin 3 alpha. Similarly, this power will come to the argument. It is cos 3 beta plus I sin 3 beta. And again the power cos 3 gamma plus I sin 3 gamma. Remember, Moyers theorem says power will come to the argument. And once I have done the right hand side, it is a product. Product of what? 3 complex numbers. What do you mean by product of 3 complex numbers? Add all the arguments. Cos alpha plus beta plus gamma plus I sin alpha plus beta plus gamma. So we have added the arguments. 3 into cos, add all the arguments, plus I sin, add all the arguments. Now to bring about the expected result, let us compare the real and imaginary. Compare the real imaginary parts. What do you mean by real? All that is without I. So cos 3 alpha, cos 3 beta plus cos 3 gamma equals to, right hand side I have 3 cos alpha plus beta plus gamma. So I have compared the real. Now let me compare the imaginary. What is the imaginary? All that is with I. So I will write sin 3 alpha plus sin 3 beta plus sin 3 gamma equals to, what is with I? There is a number 3 which is out, into sin alpha plus beta plus gamma. And so I have achieved the 2 results using 2 different ideas. Number 1, the power comes to the argument in product. So Moyers theorem. Number 2, multiplication means we add the arguments. And very important result, whenever they give cos and sin separately, we remember the idea. Cos plus I sin only helps us in polar form. So there are 3 different arguments. Consider 3 different complex numbers with alpha, beta and gamma. and by adding I am able to show 0 plus I0, and whenever the total of A plus B plus C is 0, I can immediately remember the algebraic result. A cube plus B cube plus C cube equals to 3ABC, and this paves this result. Exercise 2.8, question number 4. So the problem given is 2 cos alpha equals x plus 1 by x, 2 cos beta equals y plus 1 by y. I want to find out 4 different answers: x by y, y by x, xy, minus 1 by xy, x power m, y power n. So all these things can be achieved easily provided I write x and y using polar form. So let me consider this first part. 2 cos alpha equals x plus 1 by x. Cross multiply, I get 2 cos alpha x is equal to, here x square plus 1. I am throughout multiplying by x. So 2 cos alpha x, x into x plus 1. The next step, bringing everything to the same side. X square, bringing this to the other side, minus 2 cos alpha x plus 1 equal to 0. Find out what is x then. What formula is this? X is equal to minus b plus or minus root of b square minus 4ac by 2a, or x is equal to, here this is a value, this is b value, this is c value, 2 cos alpha plus or minus root of b square, 4 cos square alpha minus 4 into 1, 4, divided by 2a. Simplifying the answer, 2 cos alpha plus or minus, in both the terms 4 common, take it out. It comes out as root of 4. Even I can write root of minus 4. So I am taking minus 4 out, means it is 1 minus cos square alpha divided by 2. X is equal to 2 cos alpha plus or minus, minus 4 means it is 2i. 4 means it is 2. Minus 4 means 2i. Root of 1 minus cos square alpha becomes sin square alpha. Root of sin square alpha is sin alpha. The whole thing divided by 2. So I am able to achieve what is x from here. All the 2's will get cancelled. I get cos alpha plus I sin alpha. So whenever they give you 2 cos alpha is equal to x plus 1 by x, by cross multiplying, solving, I am able to achieve what is x? Cos alpha plus I sin alpha. Now there is a question. Do I have to achieve all this? Of course, there is a shortcut. The question says x and 1 by x, and the left hand side says alpha. So take x is equal to cos alpha plus I sin alpha, because alpha comes in the question and x is there. What is 1 by x? A little before we learnt reciprocal means conjugate. So cos alpha minus I sin alpha. So what about x plus 1 by x? That is equal to 2 cos alpha. So whenever they give you x plus 1 by x is 2 cos alpha, you can immediately declare x is cos alpha plus I sin alpha and 1 by x is cos alpha minus I sin alpha. Similarly, 2 cos beta is y plus 1 by y, means 2 cos beta equals y plus 1 by y, implies what would be y? It will be beta. Cos beta plus I sin beta. And what is 1 by y? Cos beta minus I sin beta. So I can just use the word similarly. And I can write this answer. So we have achieved what is x? and what is y. So these are the two important things that will be used in achieving these results. So given a problem like this, either use quadratic method or you use polar form method and arrive at x is equal to cos alpha plus I sin alpha and y is equal to cos beta plus I sin beta. Now we will proceed to find out these results. There are 4 questions. So we will substitute what is x and y in all this and try to achieve the result. What is my first result? X by y plus y by x. X by y plus y by x is equal to, I want to show 2 cos alpha minus beta. So this is what we want to prove. Let me find what is x by y. What is y by x? Reciprocal. So x by y is cos alpha plus I sin alpha divided by cos beta plus I sin beta. And what about division? Division means subtract the argument. Here alpha, here beta. Division means subtract. So how will I write it? Cos alpha minus beta plus I sin alpha minus beta. What is the next step? Y by x. What is y by x? Reciprocal. So 1 by x by y. That is 1 by cos alpha minus beta plus I sin alpha minus beta. And what do we know? Reciprocal means denominator plus symbol will go to the numerator as minus symbol. So reciprocal in polar form is conjugate. So cos alpha minus beta minus I sin alpha minus beta. Now that I know x by y and y by x, my next step is to add. So x by y plus y by x is equal to plus I sin minus I sin will get cancel. Cos plus cos is 2 cos alpha minus beta, and that is the result. So we shall mark this is 1 and this is 2. 1 plus 2 gives me the required result. Second part of it, to prove that xy minus 1 by xy equals 2i sin alpha plus beta. So we'll first find out what is xy. X is cos alpha plus I sin alpha and y is cos beta plus I sin beta. And we know multiplication means add the arguments. So cos alpha plus beta plus I sin alpha plus beta. This is 1, let me see. I want 1 by xy. That is the reciprocal. 1 by cos alpha plus beta plus I sin alpha plus beta. And what is your result? Whenever I write reciprocal, the plus in the denominator will go as minus. Argument, there is no change. Only this plus I will go as minus I. Sin alpha plus beta. Call this as number 2. So what is 1 plus 2? Xy plus, this question is minus actually. So we are going to subtract. So 1 minus 2. Xy minus 1 by xy means, what is xy? Cos alpha plus beta plus I sin alpha plus beta. And what is 1 by xy? Cos alpha plus beta minus I sin alpha plus beta. I want minus symbol. So this is minus and this is plus. So what is my answer? Cos and cos will get cancel. I sin plus I sin is 2I sin alpha plus beta, and that is the result. So xy minus 1 by xy gives me 2I sin alpha plus beta. Third subsection, x power m by y power n minus y power n by x power m equals 2i sine m alpha minus n beta. What is x power m? X is cos alpha plus I sine alpha the whole power m. M by Moivre's theorem will go to the argument. Power comes to the argument. So it is cos m alpha plus I sine m alpha. What is y power n? Y is cos beta plus I sine beta the whole power n. Again by Moivre's theorem, power comes to the argument. So I have x power m, y power n. I want to divide. So x power m by y power n means cos m alpha plus I sine m alpha divided by cos n beta plus I sine n beta. Division means subtract the argument. Cos, here m alpha, here n beta, subtract. M alpha minus n beta plus I sine m alpha minus n beta. Call this as number 1. Now I need y power n by x power m, just the reciprocal. So it is 1 by x power m by y power n. So 1 by cos m alpha minus n beta plus I sine m alpha minus n beta. That is equal to denominator plus symbol will go to the numerator as minus symbol. M alpha minus n beta minus I sine m alpha minus n beta. Call this as number 2. My question is subtraction. So 1 minus 2 implies. What is 1 actually? X power m by y power n. And what is 2? Y power n by x power m. And I need to subtract. That is equal to. When I subtract, cos and cos will get cancelled. I sine minus of minus means plus. Earlier we did same method. Cos and cos will get cancelled as I subtract. This is I sine plus I sine. So my answer is 2I sine m alpha minus n beta. Subsection 4. X power m into y power n plus 1 by x power m into y power n equals 2 cos m alpha plus n beta. Now that we have done 3 subsections, this is more or less the same. X power m, y power n we can use from the previous section. I want x power m into y power n. That means cos m alpha plus I sine m alpha into cos n beta plus I sine n beta. What do you mean by multiplication? We add the arguments. So that is cos m alpha plus n beta plus I sine m alpha plus n beta. So this let me call number 1. And I need the reciprocal. 1 by x power m, y power n. What do you mean by reciprocal? Change the symbol. Cos m alpha plus n beta plus I will become minus I sine m alpha plus n beta. So as we have done many subsections, you can immediately write this. Whenever I want reciprocal, plus I will become minus I in polar form. The next step, I need to add x power m, y power n plus 1 by x power m, y power n equals to, as I am adding, cos plus cos will become 2 cos m alpha plus n beta. Plus I sine minus I sine will get cancelled. So this is the answer expected. Such a big problem, any 2 subsections may alone come under 2 or 3 marks, or all the 4 comes, it may come under 5 marks. So this is a great milestone, as I have already said. about De Moivre's theorem, polar form, product, division, reciprocal. So a very important as well as a challenging problem. Write it twice or thrice and learn properly. Thank you.